Hi folks, and welcome back to Physics with Captain Rod. I'm making this one to help you out with your Unit 1 homework, numbers 19 and 20. So let's see, 19, it says a skydiver jumps out of a helicopter and free falls for 8.6 seconds before opening his chute. So I would write that number down, 8.6 seconds. Again, like I've stated many times, the homework is designed to give people different numbers, so your time may vary, maybe some different value, but you should be given a time in your homework. Let's see, what is the downward velocity when the parachute opens? All right, so acceleration is equal to change in velocity over change in time. And hopefully you've watched my video on gravitational acceleration. When you drop an object, right, the object will accelerate down at about 9.8 meter per second, or in English units, about 32 foot per second. So what we're going to do is we're going to use this value here as our acceleration. And then we're going to go ahead and calculate, let's see, a change in velocity, and that'll be some number. Now, whether the acceleration is positive or negative is kind of a viewpoint thing. It depends on if you decide to call up positive or down positive, and it doesn't really matter which in this problem. I guess technically, let's do this. Let's call up positive. If we do that, when you put the acceleration in here, put negative 9.8 meter per second for the fact that the acceleration is down. Then put your delta t in, and delta t's are always positive. And then for your change in velocity, you're going to get a negative number, which is perfectly fine. That just means that the velocity is down in the problem. Now, this one's the first one that I've worked on here with you folks. That's going to require a graph. So where it says how far below the helicopter is the skydiver when he opens his chute. All right. To answer this, I would draw a graph of velocity against time. And when the object is first drawn, its velocity is 0. So that data point's going to go here. And then 8.6 seconds later, meaning we're going over here to 8.6. Now, in your homework, this might be a different number. Our velocity is going to be whatever we got here. Now, you don't need the minus sign, and now it's getting into kind of nitty-gritty details. I'll just say this. For this problem, you don't need the minus sign. Just come up over here to whatever that number is, ignoring the minus sign. Put it on the graph. Connect the dots. And again, remember that acceleration is the slope of a of a velocity graph. So when we connect the dots linearly like this, what we're doing is we're making a constant acceleration assumption. And then the distance traveled is going to be this area right here on the graph. And again, hopefully you've watched my videos on how to find a displacement from a velocity graph. So this one's probably kind of the most involved here of the ones I've done so far. I'm going to get rid of this. Let's talk about number 20. So 20 is very similar. A rock dropped off a bridge. So here's our rock. Whoops. And then the motion diagram for the rock might look something like this because the rock is moving faster and faster. And let's see, what is the velocity when it hits the water? So I would start by writing out acceleration is equal to change in velocity over change in time. Go ahead and use 9.8 meter per second for that number. This number is given. Okay. I would then go to part C, right, where it says, what is the height of the bridge? Draw your velocity graph. And again, here, the rock started at 0 meter per second, so that's going to go here on the graph. The final velocity at this point you're getting from this number right here, so that's going to go over here somewhere. And again, the time here is given. Connect the dots. Now, to get the height, that's how far this object moved. That's this distance, and you're going to get that from this area right here. 1/2 base times height is going to give you the distance that that rock traveled. or we call that the displacement. So we sometimes call that a change in position, or maybe a delta x. Right? And velocity as a vector is equal to delta x over delta t. I know there's lots of different formulas here. Anyway, to get the average velocity, part B, take the delta x, and that you're getting from the area, divide by the given time, and you're going to get a number. And that number represents the average velocity over the entire time interval. So hopefully that helps get you through that problem. I hope you're enjoying things so far. I'm going to end that one there. Have a nice day.